Welcome, and thank you for joining Plum Grid and Red Hat for this financial services webinar today, where we're doing design and deployment of secure clouds. So I just wanted to take a few minutes to quickly welcome you and introduce you to our event center. Everybody is on mute, and we are recording this session. So after the session, we will be sharing the recording with everybody, as well as spending some time doing Q&A at the end of the session. There is a Q&A panel that you can use to ask questions throughout the session, and we'll do our best to address them all. So without further ado, I'm going to pass it over to Justin and Joe so they can introduce themselves and the topic. Thank you.
All right, guys, thank you for joining. As Deb mentioned, my name is Justin Moore, a principal architect here at Plum Grid. Most recently, I joined Plum Grid from American Express, where I led the Cloud Services Division. And so my background is primarily in financial services as a architect and director, and now working for Plum Grid to help other companies in financial services build and deploy cloud infrastructure as well. Joe?
Hello, everyone. My name is Joe Enkowiak. I am with the OpenStack Tiger team at Red Hat, and my team is responsible for making sure POCs work correctly and field enablement around OpenStack on the commercial side.
Great. Justin, can you take us through the agenda real quick?
Yeah, absolutely, guys. Great. So I've got the agenda slide up here. So we're going to talk about a couple of things today. First and foremost, OpenStack infrastructure security. So this is a joint presentation between Plum Grid and Red Hat, and we're going to show you how jointly Red Hat OpenStack and Plum Grid ONS can be used to design secure cloud services. Second, we're going to talk about security and compliance. Again, the main focus of this webinar is to talk about security. How can we have clouds that are both secure and compliant with our regulatory agencies? And finally, we're going to introduce a topic known as micro-segmentation. And we'll talk a little bit more about what micro-segmentation is, and we'll demonstrate this for you through a recorded demo. With that, I'll turn things over to Joe.
Deb, do you want to make it? Yeah, there we go.
There you go.
So, quick agenda for the Red Hat portion of this webinar. We're going to go through a couple things, mainly talking about some of the common security challenges that we see with OpenStack infrastructure deployments, and then ways that we can address these challenges with both the OpenStack platform director components as well as Red Hat Cloud Forms. So some of the common challenges we see with OpenStack infrastructure around security. The first thing we see a lot is oftentimes in both during and after deployment of OpenStack, there are a lot of manual tasks involved, applying policies, ensuring certain packages are applied and different pieces of configuration. The challenges with manual tasks, a couple of them, they're not always repeatable. They're often up to interpretation, not always completely consistent, not always sure that they're completed in the same manner each time they're completed. And basically a lot of manual tasks can turn into drift and differences in configuration, and it doesn't always adhere to security policies and configuration that's been defined for your organization. A second issue is a lot of times we'll see security configuration applied post-deployment. So this lengthens the deployment process significantly and has some of its own unique challenges. Other challenges we've seen are detecting changes and enforcing policy after an OpenStack environment is deployed. It's a very frequently recurring challenge. and then maintaining the security configuration and policy when you are upgrading OpenStack to different versions, and then also scaling, adding compute nodes and such. So there's two main pieces that we are going to talk about that can help address these security challenges. One is the OpenStack Platform Director, and this is a component of OpenStack Platform. It's based on OpenStack projects, existing OpenStack projects, and we'll talk about some of those details. It's targeted as a day one and scaling and upgrading tool. The second component is Red Hat CloudForms. Red Hat CloudForms is included in the OpenStack Platform subscription and is targeted as a day two and lifecycle tool. So the first thing we'll talk about is some of the components of Red Hat OpenStack Platform Director. So Director is kind of targeted for a number of things. It's an integrated orchestration tool for planning and deploying, configuring, and upgrading and scaling OpenStack. It is a combination of existing OpenStack projects, mainly projects such as Ironic, O, and Heat. Basically uses these existing projects or these OpenStack projects to manage the OpenStack and deploy the OpenStack infrastructure themselves. A little bit more detail. So one of the biggest advantages of using Director overall is that a lot of the concepts that you're already used to with OpenStack in terms of images and instances and managing your nodes and such, and managing the workloads. A lot of those same concepts are now also applicable to the OpenStack infrastructure itself. So this kind of provides two different, two components of this functionality are that your OpenStack deployment itself is now both image-based and template-based. And this has these two aspects have a number of security advantages, security configuration and simplification advantages. We'll get to some of those details. But overall, an image-based deployment of your OpenStack infrastructure first is based upon a standard image that you've defined, you can customize, you can add to, you can subtract from. Basically, create an image that is tuned to what your organization needs, and then from there in the actual deployment, you can also further customize in a template. And those templates become reusable and standard. So overall, OpenStack Platform Director is basically using OpenStack to deploy OpenStack with images based upon Heat templates that are defined. So that has a number of advantages. So in terms of image customization, a lot of times we'll see customers wanting to go through a number of different customizations for their images. Some good examples of what we've seen and what we've implemented for customers. First of all, one is a specific version of a kernel. So this is a specific image customization aspect where, let's say you wanted to use a hardened kernel or a different kernel version or a custom build, compiled kernel. That's something that can be done and deployed easily and repeatable with OpenStack Director in the custom image that you can define. Second, we often see packages, specific packages needing or required by our organization, whether that be different versions of packages or additional packages like for different security tools and SDN tools and SDN packages. So those are things that can be included and changed in images, and then local accounts and policies. So if you have additional local accounts or additional SE Linux policies or any other general across-the-board requirements or policies that you define in your standard images when you deploy an OpenStack infrastructure, these can be included in a customized image. And basically, you're then able to use this image with all of these policies defined or these changes defined in your deployments of all of your OpenStack nodes, both control and compute. The second aspect to that is the components that you can customize in the templates. So when you are deploying OpenStack with Director, you first of all use your standard images that are defined, and second, you have heat templates that are defined and created with a number of customization and configuration parameters. From the security perspective, there are a number of changes or configuration options that we often see customers wanting to make, and these are supported and functional through Director templates. The biggest one we see is enabling SSL or TLS for both control plane communications and endpoint. So this isn't just enabling a self-signed certificate, but actually using a certificate signed by your CA and using that in the OpenStack environment to secure those communications right at the start. So it's not an afterthought. You're not going back in and adding security later. You're doing it during the installation, and that can become part of the template. Second common implementation request has been AAA integration. So in the Director templates, you can include things like LDAP functionality or LDAP integration with Keystone, and also Kerberos and other AAA systems. Those are included, or those can be included in the Director configuration, Director templates for OpenStack configuration. So you don't wind up having to go in after the fact and apply a lot of these settings or apply a lot of these config changes to the environment after the fact. These are included in your templates. They're repeatable, reusable, and standardized. And third thing we see a lot of are things like services, like your network and system services, like logging destinations, NTP, monitoring tools, and other even security tools like Nessus can also be defined in there. But basically, instead of having to go into nodes after the fact, after deployment, you can include these options, include these changes in a template that will be consistent across your deployment of OpenStack. So some of the real advantages to both the image and template-based deployments are that it's ensuring consistency during upgrades and scaling. So the same template and images that you've used for, or the same changes you've made for one version of OpenStack, you can also apply to the next version of OpenStack when you're going through that upgrade. There's less manual work involved because you're templatizing everything. It's easily repeatable, and that your security policies and configuration winds up getting applied at deployment time. So there's significant advantages there to kind of roll that all up into one process for installation, including all the security aspects. So from there, we'll go into CloudForms. So CloudForms is a very broad product. It basically is a unified cloud environment orchestration tool. For the purposes of this discussion, we're going to focus specifically on the compliance and governance aspects, and we'll get into that in a moment. But there are many other aspects to CloudForms. And once again, CloudForms is a included product in the Red Hat OpenStack platform subscription. So if you haven't looked at CloudForms before, there's a lot of advantages there. But specifically for security-related aspects, for compliance and governance, there are three main functions that are relevant for security. The first one is analysis. So through a function called a smart state analysis, CloudForms can basically and does go into both the OpenStack infrastructure nodes and can also interact with the workload nodes on the OpenStack infrastructure. But basically going in and analyzing and tracking a long list of details about the operating system and the packages and files, and we'll go through that list of what some of those details are. But there's a lot of analysis and record keeping information available through the smart state function in CloudForms. The second function that's important on the security side with CloudForms and OpenStack is tracking and alerting. Now this is significant in that once an item has changed or some type of drift has occurred to the OpenStack infrastructure nodes themselves, or the nodes or the instances running on OpenStack, those can be reported and alerted on based on your policies. And we'll go into granularly what some of those types of changes are, but it is very powerful in that the types of notifications and constant watchful eye of what's different, what those possibilities are. And the third feature is the remediation aspect. In your defined policies and configuration, you can actually set a policy or set a config that will either go in and remediate or change back a setting that was changed, or even kick off a more in-depth analysis of a node. So let's say you through your regular analysis process, you've discovered a change has been made to a package on one of the nodes. You'll alert on that, but then also trigger a script that can go in and run something such as, I'll bring up Nessus again, a Nessus host scan on that node, and then report back those results. And those are the types of things that can be automatically kicked off in CloudForms. So it's some big advantages for the security side here. So in the smart state analysis, a number of things that are tracked. First thing, the biggest thing is packages and files. So package versions, new packages that have been installed, version changes, new or changed files on the node. So that can be pretty significant if you're trying to detect a node that's been compromised. Second item are a lot of like local users that have been created or changed, local groups or actions performed by local users. Those are recorded and tracked and can be reported on and alerted on. And then component changes. We see things like we're tracking things like any additional network interfaces, like let's say someone brought up a new VLAN interface on a node that's outside of OpenStack, or a new network attached storage mount somewhere, or things like a new instance or a container that is not part of the OpenStack managed instances, something like that showing up. So those are some examples of things that can be tracked by CloudForm's Smart State, and then obviously reported on, and then can automatically kick off scripts and other actions that you deem appropriate. So I hope that's been a good overview of some of the security capabilities or security features and functionality with Red Hat OpenStack platform and Red Hat CloudForms. I know there's been a number of questions posted. Please post them in the webinar Q&A, and we'll answer those at the end of the session here. Please also, if you're going to be at OpenStack East next week, please visit us. We'll be there. We can provide a detailed, more detailed demo, more detailed discussion, and then also obviously check out the information available at our website on both OpenStack and CloudForms. Thank you.
Mm-hmm.
Okay,
great. Well, thanks,
great.
Joe.
Just pass the ball over to you, Justin.
All right, great. Well, thanks for that overview, Joe. And guys, as we talked about earlier, we are going to mix in some real-world examples as well. So we're going to spend a few more minutes talking about security and compliance, as well as some of the theory behind the design, and then we're going to jump into an actual design, and the demo will show you a real-world application. So with that, why don't we get started? So as Joe mentioned, a number of technology challenges facing financial services. We've got regulatory and compliance concerns. A number of you either are or represent clients who have PCI requirements or Sarbanes-Oxley requirements. Separately, of course, security requirements. We all know that security and compliance don't necessarily mean the same thing, and so that there are oftentimes more stringent requirements from the security department in addition to some of those requirements that you need for your regulatory compliance. Security is interested primarily in separation of concern, things like minimizing the attack surface of any given application, and strict enforcement of access control, right? We want to have tight coupling between the infrastructure, the application, and the access control device. From an operations perspective, I know that we're always being asked to do more with less, and so this oftentimes comes down to standardization and automation, so reducing manual effort. One of the biggest challenges facing financial services, I think, comes from within. Many times, the security vulnerabilities are opened by mistake. Many times, misconfigurations in applications or misconfigurations in firewall rules have led to unfavorable audit findings. And so we have to find a way to address those. It's not going to be with more stringent processes. We've tried that for a long time, and we still have unfavorable audit results. It's going to be through automation. Finally, I think from a business perspective, there's this need to be able to scale quickly. Everybody's aware of AWS and how quickly we can scale applications on demand. This should be the case across your entire infrastructure, not just your public cloud infrastructure, but also your on-prem data center equipment as well. So how do we solve this, particularly when traditional approaches no longer work? We like to break this down as better, faster, cheaper. The traditional methodology, we've got ticket-based workflows. I think you're all probably familiar with those. Sometimes it takes days or weeks to get new services stood up as the ticket gets passed from a data center engineer to a systems engineer and a network team and a firewall team. You're probably also familiar with agile development methodology. And so many of you may either represent clients or be in the situation where application development is shifting towards agile. They're asking for infrastructure to be available on demand, and this does not line up well with the traditional manual ticket-based approach. Again, when we talk about things like continuous delivery, continuous integration, it's very difficult from an infrastructure standpoint to keep up with CI/CD if you're relying on people and processes to make that infrastructure available. We talked a little bit earlier about adding automation and standardization. One of the major benefits here is reducing human error. The human process, even though we're following a checklist, leads to configuration drift, or it leads to people making mistakes. Any one of those things can lead to an unfavorable audit finding, or worse, could lead to a security vulnerability which might be exploited. And finally, I think you're all well aware that our CIOs and CFOs are asking us to continually do more with less. So how do we reduce the overall cost of our infrastructure? The traditional methods for scaling up require buying bigger and bigger access control devices to handle more and more throughput as we add more customers to existing systems. Probably also aware that doubling the throughput of a device doesn't just double the price, it usually triples or quadruples the price. And so you've got this multiplicative effect on the cost of your infrastructure. And finally, we also have highly skilled engineers. We've got people who hold advanced certifications or degrees, who've been working in the industry their entire careers. And we're essentially paying them to work from a ticket queue to do things like build a server from a CD or a box, but manually making modifications where they have skills that will lend themselves to much more business related or highly important work for the business. So I think if you're here on this webinar, you've come to one conclusion, which is cloud will help us solve this problem. And that's true. It will help us solve this problem, but it's not the whole story. It's not the only part of the story, particularly when we talk about things like compliance and security. Being able to simply stand up a server is not the same thing as being able to stand up and manage a secure server. It's not the same thing as being able to deploy an application in a way which will meet your regulatory requirements. And so we have to have another layer of control, something which ensures that we've got strict access control. So software-defined networking comes to mind. SDN controller is a tool which essentially will help you automate some of the networking components. Things like access control, things like virtual network functions and routing. This, again, is another step in the right direction, but it's not the whole story. We have to come up with a way of ensuring that security is built into the system, and then it's provided end-to-end in the environment. So what we're going to talk about today, a topic many of you are probably familiar with, if only from the terminology, is micro-segmentation. A lot of buzz in the industry right now around micro-segmentation. If you ask any SDN vendor the way to secure an environment, they're going to tell you micro-segmentation. What we're going to talk about today is what that really means and how that's different from what we do today. And so micro-segmentation very clearly is simply the process of controlling access to and from a service based on the combination of the security boundary and attack footprint. So that means we're not only segmenting out our applications based on the control which is exerted on the interconnected network. So we're not only relying on security boundaries like Internet Edge or Partner Edge DMZs, but we're also adding in the second combination, which is the attack footprint. So instead of grouping all of our Apache and IIS web servers together within the Internet Edge security boundary, segmenting your Apache servers from your IIS servers within that security boundary. And there's a very simple reason for that. What you wouldn't want is for either your IIS or Apache server to be compromised and then to be used as a jumping off point for attacking the other servers within that security boundary. The legacy security boundary-based approach, of course, means the servers connected to the same VLAN do not pass through an access control device. And so that can lead to things like a security staging server internally. And we're going to address how this will occur in the cloud model and the methods of automation which are available. All right, so we're going to talk about a specific function inside of Plum Grid ONS. ONS is a platform offering from Plum Grid. Plum Grid is a software-defined networking company. We treat OpenStack as a first-class citizen, and we develop a plugin for our platform for OpenStack. Plum Grid, though, is a software-defined networking platform which supports containers, bare metal servers, VMware as well. And so don't think of this only as a SDN for your OpenStack environment. This is a software-defined networking tool which spans your existing footprint as well as your new cloud and containerized based workloads. And so one of the central tenets, one of the central design principles inside of Plum Grid ONS is the concept of virtual domains. And you can think of a virtual domain as just an isolated private data center. Basically, it creates a walled garden around a tenant inside of OpenStack or a virtual domain inside of your data center. And this can be used for anything from deploying business units IT to application-specific workloads. What we're going to talk about today is an application that we're going to call the customer service tool, and we're going to demonstrate how we can leverage both virtual domains and security policy to provide automated, secure by default delivery of applications. But a couple of things to know before we move forward. As I mentioned, we've got two virtual domains here. Those virtual domains are walled gardens around some subset of infrastructure. In this case, we're going to wall off an entire application stack from another application stack. But something unique to Plum Grid is the concept of the service virtual domain. And the service virtual domain allows you to set global policies across tenants. Traditional OpenStack model gives tenants control. All security policy is defined within the tenants. But we understand, of course, that in the enterprise, many times we prefer the centralized function like InfoSec is responsible for a global security policy. And the service virtual domain provides a way for security administrators to apply common policies across infrastructure and across tenants and applications in the cloud. One other differentiator here that I want to make note of, this is fully distributed, and so we're not routing through a centralized network node. If you'll remember earlier, we talked about the forklift upgrades and the expense of adding more capacity. Because we distribute our access control mechanism and our distributed data plane on each one of your compute nodes, as you add more compute capacity, you're also adding more access control capacity. And so we don't have a centralized piece of infrastructure where we're routing traffic that has to be upgraded as more throughput is necessary, but we scale horizontally. So as you add more capacity at the compute layer, you're also adding more capacity at the network layer. A little bit more about Plum Grid virtual domains. Again, they provide secure tenant isolation. This is a coarse-grained access control. We isolate one set of infrastructure from another set. This is one component of micro-segmentation. This provides isolation between a dev test environment and a production environment, as an example. Again, it's a fully distributed network function, so this exists in the kernel of each one of your compute nodes, and we don't rely on centralized infrastructure for processing this traffic. And finally, we have segmentation, the edge policy enforcement point. So in each compute node's kernel module, IOvisor kernel module, we make access control decisions. And what this means, again, is as you add more compute capacity, you automatically get more network capacity and access control capacity. It also serves as a point for us to integrate with our policy-based services, including virtual tap and service insertion. So just a quick primer before we jump into the application. How does Plum Grid ONS work? It works in the same way that you're used to from OpenStack, with a couple of differences. First, we have a segmented control plane. These Plum Grid directors run on your existing OpenStack controllers, and they're control plane only. They're not necessary for the processing of traffic. If all three of these nodes in the cluster were to go down, data continues to pass, traffic continues to pass, although you won't be able to deploy new topology changes until at least one of these directors is back up. Within the cloud and within the overlay, each virtual machine is able to communicate directly with another virtual machine, whether it be on the same server, in which case no traffic gets put on the wire, or whether it be between compute nodes, in which case traffic is sent directly to the receiving compute node. At no point does communication within the cloud traverse some centralized infrastructure. We don't send any packets up to the director to be routed back down to an instance in the cloud. We have one final component, which is the IOvisor gateway, and this is just very simply a VXLAN termination endpoint. Since VXLAN is the foundation of our overlay network, there has to be some method for your non-VXLAN traffic to interact with the VXLAN overlay. And so all the gateway does is strip off the VXLAN headers and places it onto your legacy network. So again, this is outside the flow for cloud traffic. When you want to communicate with the cloud with services that are off cloud, only the traffic will pass through the gateway just to have the VXLAN header removed. All right, with that, as I mentioned, we're going to talk about the real-world application. And maybe you've seen this at your customer sites or you have this yourself, the customer service tool. And like any application in the enterprise, we have a need to test and validate before pushing into production. But we also have a need to make sure that production doesn't accidentally point to development endpoints or vice versa. As challenging as it might seem, it's still an issue in large enterprises, configuration management. Sometimes a config file gets pushed into prod and a production endpoint is pointing back to a development database. And so we're going to talk about some of the mechanisms in place that will ensure that we're not inadvertently communicating with the wrong environment. But from a high level, you should recognize that the format of this slide, all we've done is we've taken the development infrastructure used to support the customer service tool, and we've put it in one OpenStack tenant or one virtual domain inside of Plum Grid. And then we've taken the production infrastructure that supports the production version of the customer service tool, and we've put it into a separate tenant in OpenStack and virtual domain. And so this provides us coarse-grained access control, and by default, there won't be any communication between dev and prod. So this means that if you accidentally have an endpoint in your dev environment pointing to production, you won't be able to access or make changes inadvertently into prod. Similarly, global cloud policy can be set by the InfoSec team at the service virtual domain. And so this is the cloud policy which governs things like shared services or global policies which need to be applied to all systems and services. So the customer service tool, we can consider a design pattern known as the 3-tier architecture. Just a presentation tier where we've got some web servers out facing, in this case, the intranet, although it could also be internet facing if the application were. Middle tier, we've got the business logic environment. So this is just the application servers that are doing the heavy lifting. And finally, we've got the database. And so a couple of design principles here. The presentation tier should never be able to talk to the database directly. You wouldn't want something in your edge boundary to be able to reach your database because a compromise on one of these edge services could lead to a compromise to your customer data. So there has to be strict firewalling and access control between these tiers. Presentation can talk to logic, logic can talk to database, and that's it. So how does all this happen? Inside of Plum Grid, we've got a well-defined policy path. The first step is group classification. We can classify on a variety of metrics. First and foremost is IP notation, tagger notation. So we can classify based on IP and port combinations. This is for consider legacy applications communicating with cloud applications. More importantly, though, we have the capability of classifying individual instances. And so you can tag an instance as being a web server, for example, or an application server. And that classification will follow that instance no matter what network it's connected to and no matter what IP address it has. So even if somebody were to make a misconfiguration on the host or connect it to the wrong network, that access control policy will always enforce the right access control on that instance. Once we've classified, we pass on to the stateful security groups. Security groups are the second half of micro-segmentation, and we'll talk about those in a minute. But those security groups are creating the policies which create the isolation between the three tiers of that three-tier architecture within the same tenant. From there, if traffic is allowed to proceed, we can insert any of our policy-based offerings. So we can set a policy-based VTAP. It's a pretty robust virtual tap device where we can mirror off traffic based on a set of criteria. Or we can insert certain devices, third-party devices or service chains like hardware firewalls or IDS, IPS devices. All right, with that, we're going to jump into a demo, and I'll just set it up before we start displaying. What you're going to see here is that customer service tool application. We've created two tenants in Red Hat OpenStack, one for the development customer service tool, another tenant for the production customer service tool. And we've done that, as I mentioned before, to provide isolation between dev and prod. And then we're going to show you through a combination of security policy how we limit access between the tiers of the application through metadata tagging of those instances. And so let me just jump on over and share this. All right, and I'm hoping that you all can see my screen.
Yeah, it's good.
Great, thank you. All right, so let's kick things off here. We're going to log into our cloud environment. Again, it's a Red Hat Linux OpenStack platform. And the first thing that you're going to see once we log in, we're going to choose between the projects. So the dev customer service tool or the production customer service tool. We're going to choose development first, and we're going to take a look at which instances we've deployed. And as I mentioned, this is a three-tier architecture, and so you'll see the three tiers. You're going to see a web server, development web server here, development app server, and a development database server. And those are on IP addresses 153, 154, and 155. So now we're going to take a look at our security policy. So how do we apply this group classification to these instances, and then what do we do once we've classified those instances? So inside the security policy, you're going to see, again, three separate policies corresponding to the three tiers: web, app, database, and then our default policy. So let's take a look at those security groups. In the web tier, what you're going to see is that we allow HTTPS traffic ingress over port 443 from the internet, so anybody can access our web server. But when we talk about the app server, we have a different set of requirements. The app server shouldn't be available from the internet. The app server should only be available internally on our network. So you're going to see that we configured rules for the app server that allows it to be accessed over port 8443, secure port, only by servers that have been tagged as web servers. So servers that are in that web security group will be able to access the app servers over that port. And finally, what you'll see with the database connectivity is that the database server again, is only available internally and can only be accessed from the app server over the MySQL standard interface. So you have to be a member of the app server group to even access the database. So what we'll show you before we move into some actual tests here, we're just going to verify that our web server, for example, has the security group policy applied for web servers and our default security group, of course. And you can see here that web and default security groups are tagged to the instance. Similarly, with our development app server, you'll see that we have the app and default security groups applied. And finally, with the development database server, you're going to see that we've applied just the database and default security groups. All right, so let's do some tests. We're going from my laptop, and we're going to curl against the development web server. And so we should get back some HTML that says, yes, we're connected to the development customer service tool. So that's great. That's expected. But the web server has to be able to talk to the app server. And as we talked about earlier, this dev web server should be able to talk to the dev app server over port 8443. And we're just going to make sure that works with curl again. You can see here that it does, and that we can talk to the dev customer service tool application server. So finally, the application server should be able to talk to the development database. So only the dev app servers can talk to the dev customer service database, and we're just going to use the MySQL command line tool for this. And we're just going to demonstrate that we connected and that we can select some data. We're going to use our dev database, and you can see that we've selected the dev customer service tool database. So that's great. That's exactly as we expected, right? We would expect all of those things to pass. And we're going to show you that on the production side, we've got the similar configuration because after we go through this portion of the demo, we're going to show you what doesn't work by policy. So again, we'll just list here. We won't go through the full details that we did on the dev side, but again, three separate tiers: web, app, and database. And you'll see under security policies that we have, again, web, app, and database security groups applied. And the reason we're showing you this again is to demonstrate that dev, for example, won't be able to talk to prod because we implicitly disallow that. But all the configured connectivity does work. Let's just go back and run that test from our client machine and make sure that we can talk to our prod customer service tool web server. And of course that works, right? We can see that this is the production customer service tool web server. Similarly, our web server, again, our prod web server, talking to the prod customer service tool app server for port 8443. Works as expected. And finally, our app server talking to our database. And we're just going to demonstrate once we connect to the database that it is a different database. So get connected here. And you can see that it's the prod customer service tool database. So that's great. But we want to demonstrate also that disallowed access is removed or revoked. And so we're going to show here that the production app server cannot connect to the dev database. So we're going to issue this command, and we'll enter a password. Doesn't matter what we enter because we won't be able to connect to that database. And if we were to let this would just time out on its own. So the production app server cannot accidentally be connected to the development database. You would just get a database connectivity error. And let's just demonstrate the same thing the other way. The development app server can't accidentally talk to the production database. You wouldn't want your developers accidentally inserting development data into production. Again, we enter our password, and it's just going to time out. And so we won't wait for it to time out, but I think you guys get the picture here. So I know there's a lot of information in this presentation. What we really wanted to get across is that designing cloud services for financial services is possible, and it actually improves your security and audit posture. I know that there are many auditors and InfoSec team members and engineers who have concerns and valid concerns about what it means to implement cloud. But there are strong design patterns. I think we've demonstrated those today that allow you to deliver secure cloud services. As Joe mentioned, we are going to be at OpenStack East next week. Stop by our booth. We've also got an event that evening, and so if you would like to join us, just let us know. We'd be happy to have you and continue the conversation. All right, with that, why don't we open it up for questions? I know, I think Deborah had some questions flowing through. So let's see here.
Yeah, let me just unmute myself.
All right.
Let's see. Yeah, so we got questions coming through. If you have additional questions, feel free to answer. I'm just going to take them kind of as they came in. So there's a Q&A panel. Feel free to ask. If they're kind of in random order, I apologize. So let's see. The first one, it looks like, let's see, what considerations should OpenStack security administrators think of when deploying container management systems on OpenStack?
Yeah. Yep. Why don't I take a stab at this, and Joe, if you wouldn't mind jumping in as well. I think from a security standpoint, though, just like from an operations standpoint, it's important that your tools work together and interoperate. And so you shouldn't have one set of security policy that applies only to containers and another set of security policy that applies to your OpenStack environment. There should be a single tool which is pulling those environments together and allows you to set centralized policy. And so I would say that if you're a security administrator, security engineer designing a system, a cloud-based system, one of the things that you would want to consider is making sure that you have that centralized pane of control and that we're not creating our own security islands. Jody, anything you want to add to that?
Yeah, so basically some high-level concepts on that. I guess, overall containers and security is a broad topic in and of itself, but the one thing that's recurring is, figuring out who you want to trust or what sources you want to trust for the containers that you are using. There are a lot of templates and containers being created out there that haven't always been through the initial security scan and validation for a given environment. So you want to make sure you define who you're going to trust for sources, and then who who in your organization is allowed to create containers, and what are those, what are they allowed to implement, what are they allowed to run. So try to match that up with the same sort of scenario. Who's allowed to create if we're talking VMs and instances, who's allowed to create those instances or create those images, I should say, sorry. Who's allowed to create the images and make sure those policies are lined up. Because a lot of times, there's policies applied to instances and VMs, but then when you go down on the container path, those policies haven't really carried over, and that can be very dangerous. So.
Okay, and same person asked a follow-up to that question. I'm not sure what the abbreviation of INIT is, but also, how can OpenStack admins ensure that end users deploy reasonable working cloud, initiatives and heat templates?
Yeah, I think there's a couple things to think about, and I'm sure that Joe has something to add as well. From my own perspective as an OpenStack operator, we began by helping individual development teams create their first pass at their heat templates. And so the first pass of the heat template, the cloud admins helped them create, checked it into their version control, and that became part of the CI/CD pipeline. And then it was just a matter of the team making minor modifications. So it was a combination of education and some white glove treatment up front. Ultimately, for existing applications, there are fewer modifications that need to be made. But I think a combination of education and helping out up front goes a long way towards making sure those templates are reasonable.
Yeah, and just to kind of continue on that same thought, I mean, the development or the creation of heat templates and validating installation, it does tend to be in an initial deployment fairly iterative. So you make small changes, deploy and test. And there are a number of smoke tests and validation tools that can be used to verify functionality. Also, every organization has internal tools that they want to use to also validate and test all systems deployed. But just continuing to use those and understand that the first deployment, first build of a director-based install, will tend to be iterative, and then from there just continue to make small changes and implement.
Great. Okay, so we have another question about agents. Do we deploy it on endpoint VMs, i.e. anti-malware software? Can you see this question in there? This would be addressed in CloudForm Puppet to execute a time. Do you see that question?
Joe, do you see that question? That might be a good one for you.
Yeah, so actually, so CloudForms does the smart state analysis agentless. It is actually doing analysis by way of looking at the actual disk that's being used. So you can do, let's say you started with an image that you know is matching your security policies and everything else that in your specific configuration, and then you've deployed a number of instances based on that image. You can actually do a smart state analysis comparison between the source image that you ran and then the running instances, say, a day later or 5 days later, and it'll go out and point out to you all of the differences that have occurred on files, file sizes, configuration changes, all of that, all of those types of scenarios. And you can have that running on a regular basis or a recurring basis, scheduled. So you can detect deviations from the original base image. Now, for detection of malware and other security challenges that may be faced in the initial image, that's kind of a separate separate security challenge. But in terms of once you have an established baseline image to use for running instances, CloudForms can inform you of anything that winds up being different about running instances compared to that original image.
Okay, great. And so it looks like we have time for a couple more questions. Let's see. It says, you mentioned PCI and SOX compliance in the slides. Have any of your clients successfly passed their audits in this configuration?
Yeah, that's a great question. Actually, while I was at American Express, was a customer of both Red Hat and Plum Grid, and they helped us actually achieve compliance on our PCI cloud environment. And so a few years ago, I think you heard Walmart was using a very large OpenStack environment. They specifically avoided the payment card processing environment. Being an American Express, we had to bring that in the scope. And so I think both Plum Grid and Red Hat are uniquely positioned to not just design for those types of audit regimes, but also help companies achieve that certification and help their auditors understand the changes in the environment and how those changes are addressing the needs of the audit requirements.
Yeah, and so just to add to that a little bit, so the answer to that question is as Justin has answered, is yes. But specifically, the combination of the OpenStack Platform Director and then combination of CloudForms can really be very powerful and helpful to first ensure that the policies that you need to define and implement are consistent. It's not left up to interpretation or a lot of manual repetitive tasks, and then also continuously verifying that nothing has changed or being notified when something has changed. I mean, those are very, very helpful when it comes to compliance audits.
Okay, great. Let's see. I think we got time for one more question. Does OpenStack Director handle OpenStack version upgrades? Are the templates compatible with upgraded versions?
Yes. So one of the advantages of OpenStack Director, OpenStack Platform Director, is that it will upgrade environments from one version to the next. In terms of template compatibility, generally the parameters that are defined will remain in existence in later versions, but what winds up happening is additional parameters or additional customization becomes an option. So if you wind up implementing something that actually needed to instead just run some command line commands after deployment, automated through Director, in later versions, that may wind up being an easily defined option somewhere else in the template. But generally, the formats will remain compatible between upgrades.
Okay, great. Looks like it's a good time to wrap up here. We want to thank everyone for joining us today. It was an excellent event. Thank you, Justin and Joe, for your time and sharing your knowledge with this solution. So thank you everyone. We will send out the recording of the session. It will take a few days, but we will hit your inbox with that. Also, both Red Hat and Plum Grid will be at OpenStack New York next week. So if you're there, be sure to stop by, say hello if you have any additional questions. You're also more than welcome to reach out via email. You can go ahead and respond to the event email if you don't know how to contact us, and we'll help put you in touch with the appropriate people. So thanks again. Everyone have a great Thursday, and we look forward to seeing you in the future.